Myself, Harshal Nilkanta Nemade, lecturer in Mechanical Department at Praveen Patil College of Diploma Engineering and Technology. Now, numericals on sections triangular, circular, hollow circular and semicirculars. We will solve one by one numericals on each section. So, starting with first, an equilateral triangle has a side of 150 mm. Find the moment of inertia about its any one of the side. This is an equilateral triangle. Side is given 150 mm and height is not given. We will calculate that height. The blue color H indicates calculated height. How to calculate it? I will let you know. Considering a triangle ABC, sin 60 is equal to opposite upon hypotenuse. Sin 60 is equal to H upon hypotenuse is 150. H is equal to 150 multiplied by sin 60. H is equal to 129.90 mm. I have calculated the H value. Moment of inertia of equilateral triangle about lamina about the base. Now base BC. IBC is equal to BH cube divided by 12. B value is 150 multiplied by H value is 129.90 cube divided by 12. After solving, I will get moment of inertia about base BC is equal to 27.39 multiplied by 10 raised to 6 mm raised to 4. This is your final answer. Next numerical. Find the moment of inertia of right angle triangle 100 mm height and 140 mm base in the following cases. First, about an axis passing through the base. Second, about a horizontal axis passing through its CG. Third, about an axis passing through its apex and parallel to the base. Solution. We will draw the diagram. The diagram is given a right angle triangle. So I have drawn the right angle triangle which base is 140 and height is 100 mm. Let IPQ be the moment of inertia of right angle triangle about its apex. IPQ is equal to BH cube divided by 4. Substituting value of BH in the formula, I will get final answer IPQ is equal to 35 into 10 raised to 6 mm raised to 4. After getting answer, next, let IGXX be the moment of inertia of right angle triangle about its centroid. IGXX is equal to, IGXX means x-axis, centroid, is equal to BH cube divided by 36. B value 140 multiplied by H value 100 divided by 36. I will get answer IGXX is equal to 3.88 multiplied by 10 raised to 6 mm raised to 4. Let IBC be the moment of right angle triangle about its base. IBC is equal to BH cube divided by 12 is equal to 140 into 100 cube divided by 12. IBC is equal to 11.66 multiplied by 10 raised to 6 mm raised to 4. This is your final answer. Now next numerical on another section. Calculate the moment of inertia about any tangent to the circle having 990 mm diameter. Now circle is given of diameter 990. Okay. Moment of the circle about the centroid axis IGXX is equal to pi by 64 multiplied by d raised to 4 is equal to pi by 64 multiplied by 990 raised to 4. IGXX value I will get 4.71 multiplied by 10 raised to 10 mm raised to 4. Area of circle is given by pi by 4 multiplied by d1 square is equal to pi by 4 multiplied by d value is 990 square. A is equal to 769.76 multiplied by 10 raised to 3 mm square. Area unit is mm square. Now let IAB be the moment of inertia of the circle about its tangent. From parallel axis theorem, IAB is equal to IGXX plus A multiplied by h square. IAB is equal to IGXX value I have calculated 4.71 multiplied by 10 raised to 10 plus area I have calculated 769.76 multiplied by 10 raised to 3 multiplied by height I will calculate d1 divided by 2 means 990 divided by 2. Height is 495 mm. 495 I will multiply there the whole square. After solving the problem in calculator, I will get IAB is equal to 2.357 multiplied by 10 raised to 11 mm raised to 4. A hollow circular section with 200 mm external diameter and 100 mm internal diameter. Calculate moment of inertia of the section about any of its tangent. This is a hollow circular section. External diameter is 200 mm and internal diameter is 100 mm. Same moment of the hollow circular section about its centroid axis. IGXX is equal to pi divided by 64 multiplied by capital D raised to 4 minus small d raised to 4. Substituting value of external diameter and internal diameter in formula, I will get answer for IGXX is equal to 73.63 multiplied by 10 raised to 6 mm raised to 4. Cross sectional area of hollow circle A is equal to pi by 4 multiplied by capital D square minus small d square. Substituting value of capital D square and small d square, value is 200 square minus 100 square multiplied by pi by 4. I will get area is equal to 23.56 multiplied by 10 raised to 3 mm square. Let IAB the moment of the hollow circular section about the tangent from parallel axis. IAB is equal to IGXX plus A multiplied by h square. IGXX value I got 73.63 multiplied by 10 raised to 6 plus area value I got 23.56 multiplied by 10 raised to 3 multiplied by h. I will calculate D, capital D divided by 2. 200 divided by 2 is equal to 100 mm. H I will put that h value and do that h value ka square, and I will get the answer IAB is equal to 309.23 multiplied by 10 raised to 6 mm raised to 4. Next question. Calculate the moment of inertia and the radius of gyration about x-x axis and y-y axis for semicircular lamina of the diameter 100 mm. Now there is a semicircular circle of diameter 100. I will write r d divided by 2 only r because it is a semicircle. So 50 mm. Moment of semicircular lamina about x-x axis. IGXX is equal to, formula is 0.11 multiplied by r raised to 4 is equal to 0.11 multiplied by r ka value 50 raised to 4. I will get IGXX is equal to 687.5 multiplied by 10 raised to 3 mm raised to 4. Area of semicircular lamina A is equal to pi multiplied by r square divided by 2 is equal to pi multiplied by r ka value 50 square divided by 2. Area I will get 3.92 multiplied by 10 raised to 3 mm square. After area I will calculate. We know I is equal to A into k square. I is equal to A into k square is nothing but it is the radius of gyration. Means therefore IGXX is equal to A multiplied by k square xx. So So IGXX value I will substitute there. 687.5 multiplied by 10 raised to 3 is equal to area I have calculated 3.92 multiplied by 10 raised to 3 multiplied by kxx square. So I will find kxx is equal to 13.23 mm. Therefore radius of gyration considering xx axis kxx is equal to 13.23 mm. This is for kxx. Now like that only we will calculate kyy. Continue next page. Moment of inertia of semicircular lamina about y axis IGYY is equal to 0.393 multiplied by r raised to 4 is equal to 0.393 multiplied by r ka value 50 raised to 4. I will get IGYY is equal to 2.45 multiplied by 10 raised to 6 mm raised to 4. So we know I is equal to A into K square. So I will write IGYY is equal to A into K square. I will write KYY square. IGYY value I will put 2.45 multiplied by 10 raised to 6 is equal to area I have calculated 3.92 multiplied by 10 raised to 3. Now I will find KYY is equal to 25 mm. Therefore radius of gyration considering y axis KYY is equal to 25 mm. This is the final answer. Thank you.